everybody. This morning I would like to share part of my study about the application of Taguchi method for systematic optimization of ignition dimming and spark plug head range for blended fuel, gasoline and ethanol. We are One Purwanto, Martias Toto Sugiarto, Ilham Febriansyah, Riko Saputra, and Ilham Janiep. We are from Automotive Engineering, Engineering Faculty of Universitas Negeri Padang. The background of my study is because of motorcycle are dominant contribution to urban transportation emission. Small displacement spark-ignition engine often suffer for incomplete combustion. Incomplete combustion produces high CO and HC emission. Ignition system turning offer a low-cost approach to emission reduction. The objective of this study is previous study commonly examine ignition parameter individually. Lack of systematic multi-parameter optimization for ignition system, and the study aims to optimize ignition dimming and spark plug head range simultaneously. The objective is to reduce emission like carbon dioxide, carbon monoxide, and hydrocarbon emission without additional fuel consumption. The research methodology on this study is start from modification of Vega ZL motorcycle to be a fuel injection, and then we use a variation of spark plug and nickel, iridium, and platinum, and use a 3 coil where the coil is 4TB, Blue Thunder, and KDC. For the injection dimming is 13 degree, 14 degree, and 70 degree before top dead center. We use biogasoline for A80, ethanol 75, and ethanol 70%. And then we use auto RI with L9, and then we use exhaust emission tests like carbon monoxide and CO carbon, and then data analysis, discussion, and conclusion, and finish. This is the decision of experiment with the Taguchi method with 4 factor and 3 level with 9 variation of design of experiment. And this is experimental design for this study, and we can see that in here we make some variation to improve the system. And this is the result. If you use carbon monoxide to be hydrocarbon to be objective function, and we make a 9 experimental, and then we also make carbon monoxide to be objective function. And this we use a signal to noise ratio because the hydrocarbon we use signal to noise ratio is lower the better signal to noise ratio. And we compare this with using ANOVA and parameter C. It is have a higher effect or ratio. Parameter C is ignition dimming. We can see that ignition dimming 45.77% effect on hydrocarbon, and also effect on carbon monoxide. So this will be better for us that parameter of ignition dimming will be effect higher on hydrocarbon and carbon monoxide. Data analysis use the smaller the better criterion for apply the CONHC. The signal analysis evaluate performance, robustness, and statistical analysis identify the dominant ignition parameter. Key ignition timing show through the strongly influence of CONHC emission. Advanced ignition timing improve combustion completeness. Spark plug had rank at as a secondary supporting factor. Optimistic configuration significantly reduce CONHC level. And this is we from the optimization result we make a verification test to predict where is the better use carbon monoxide and hydrocarbon. And this is the verification test and this prediction test. And the conclusion of the study is to advance ignition timing enhances flame progression efficiency. Proper heat dissipation supports stable flame kernel development, and improved oxidation process led to lower incomplete combustion production and optimization achieved without additional put into the engine or the modification. So this is very important, very essential for this study. If we implement the fuel blend with pure ethanol, we can apply to unmodification system, but this better use a fuel injection engine, and then we modify a little bit the ignition timing and injection timing, because that is very essential to make combustion is better. And then from the better combustion that will be increase of power and torques, and then that will be decrease the emission of the combustion engine. And then Taguchi method effectively optimize the ignition system parameter, and ignition timing is dominant factor affecting emission behavior. As we mentioned before, that ignition timing is the dominant factor affecting the behavior, because this will be effect on combustion, that the blend the fuel and air in the combustion chamber, and on the optimization or ignition timing reduce carbon monoxide and hydrocarbon emission. And then ignition system tuning provides the practical path to cleaner combustion. Thanks for the attention, and we hope all of you guys will give us question and suggestion to make us better in future study. Thank you very much and have a nice day.